Greetings and welcome to yet another wonderful night of learning as you continue to develop your character and your intelligence by watching these videos, coming up with some questions, coming to school, working hard, working collaboratively, asking questions. You are an amazing, unique individual, and you should be extremely proud of the attitude and efforts that you have been putting forth so far this year. I know it's not easy. I know it's challenging. I know it's tiring. But you're making that choice, and that's what it's all about, people. Really, that's what it's all about. So let's get started with topic 2. Topic 2, which is another extension of Unit 3, because we're still dealing with equations on page 768. We are going to solve equations this time that have variables on both sides. And we're still going to use properties of equality. We're still going to do all those things. We're combining everything we've been talking about. We're just looking at equations that are written a little bit differently this time. Our essential question: how can you solve an equation with a variable on both sides? So let's get right to it. You should have taken down just a quick set of notes. From the top of the page, you read it, and then you look at the examples, and all it said was, hey, if you have variables on both sides, you need to combine those variables. You need to combine them. Simplify that equation by combining them on one side of the equation. And while you're doing that, just combine those constants on the other side of the equation. So let's just get right to solving equations with variables on both sides. So in number 1, we have r is equal to negative 5r plus 18. We recognize we have a variable term on each side, and we need to isolate it. Now, we can be smart. We can think it makes absolutely no difference in the whole scheme of things which side of the equation these variables are on, or which side we put the constant. So let's be smart. If we want to isolate it, we might as well put it on the other side, away from the constant. So in that particular case, I'm thinking I want to move this negative 5r to the left side of the equation. And since we're combining like terms that are on opposite sides of the equation, we have to use the opposite operation. This is how we combine. So now we have an r, we have 5 more, so that's 6 total r's is now equal to 18. Now we have a simple one-step equation where we're multiplying by 6, so we're going to divide by 6 and say that r is equal to 3. Pretty straightforward. Number 2 makes it a little more challenging because we have multiple variables, one on each side. We have a constant on each side. And then we have decimals in there. We always hate working with decimals, but it's no big deal. The process is still the same. I know you can do it. I believe in you. Might it take a few seconds longer? Sure, but you can do it. Once again, it makes no difference. We can put the y on the left side. We can put the y term on the right side. It makes no difference. I like to make my variable positive. In thinking that, I would actually move my 2.5y to the right side of the equation. Because when I subtract 2.5 from 4.5, what do I get? That's right, I get 2y. Now, ladies and gentlemen, I'm going to save myself a little work. I know that if I moved my variable to the right side, that my constant is going to go to the left side. So I might as well do that right at the same time. So now 7 is equal to 2y. Dividing by 2 to finish out solving it, we get that y is equal to 3 1/2, or since they had the equation in decimals, we could write 3.5, and either one of those would be acceptable answers. Continuing on. Now the first thing you might think of is, wow, we've got fractions. We could simplify this by getting rid of the fractions. I think in this particular case that would make more work. I recognize 1/3 is smaller than 2/3, and it's real easy to subtract that 1/3 x from both sides, giving me 1/3 x. And then I'm going to say to myself, since I moved the x term to the left side, I'm going to move that constant 5 to the right side, using the opposite operation. It's positive on the left side, so to get it to the other side, I got to make it negative. And 14 minus 5 is 9. Now I can do that. I can say I've got this fraction. I'm going to multiply the whole thing by the least common denominator. 3 simplifies out here, leaving me with x. 9 times 3, 27. That would give me the same exact answer as if I divided 9 by 1/3. So x is equal to 27. So once again, combining more things that we've learned. This time we're going to have multiple variables on each side, but before we get there, we have some parentheses that we need to simplify out using the distributive property. So I'm going to take 6 times 4 and get 24, and 6 times the negative y and get negative 6y. And that is equal to 2y. And again, we think we get smart. We might as well take that y term and move it to the right side of the equation using the opposite. So we're going to add 6y to both sides. 24 is now equal to 8y. Dividing by 8, y is equal to what? That's right, y is equal to 3. Okay, the process, ladies and gentlemen, once you understand the process of how things work, it's pretty easy. Are there other ways to solve this? There certainly are, and I could show them to you, but I don't want to confuse you too much now. I'm hoping that some of you will come to class and ask questions and generate those things that will help us see other ways to solve these types of problems. Well, this one looks kind of crazy, so we're going to have to use the distributive property twice. You might as well get started with the 6 times the 1. That gives me 6, and 6 times 1/2 x gives me 3x, because half of 6 is 3, equals 2 times x is 2x, and 2 times 1 is 2. Now, once again, it makes no difference which side we combine those variable terms on. I always go to the variable terms first. And again, this is just a Rossism. I like to make them positive. So when I take a quick glance, I say that 3 is bigger than 2. So I'm going to move the 2 by using the opposite operation. Because it's positive on the left, to move it to the right, I got to make it negative on the other side. When they're on opposite sides, we use opposite operations. So that would give me just x, because 3 minus 2 is 1. And since I moved the x term to the left side, I'm going to take that constant 6 and move it to the right side. And the opposite of that positive is negative. So now x equals negative 4, because a positive 2 and a negative 4, a positive 2 and a negative 6 give me negative 4. All right, ladies and gentlemen, that ends this first video of 3 tonight. Yes, there are 3. I'll make the other ones quick. But right here, you need to do your first quick right, which has 2 parts. I'll let you pause and write them down, solve them, take a break, come back and see me for our second of 3 videos.